Hello students, let's start with relation and functions, the very first chapter of 12th mathematics. So before learning the functions we have to learn relation, and before starting the relation we should have the knowledge of Cartesian product. Okay, and in the 11th class we have already studied the Cartesian product, and even the foundation of the relations we have already studied in 11th. Okay, so we will little bit revise the Cartesian product, then we will start the relations. Okay, and how to establish the relation, and what are the various condition, and how to recognize it's a relation or it's a function, and what is the difference between relation and function, that we will study. So let's start with the Cartesian product. Okay. Suppose the set is given. In the set P you have these elements, these three elements A, B, C, and in the set Q you have the element Ali, Bhanu, Binoy, Chandra and Divya. Okay, and you have to find out the Cartesian product of P and Q. So write this way: P cross Q. That means you are going to find out the Cartesian product of P and Q. Okay, so write. So how to write? See, take this A along with Ali. A comma Ali. Alright. Now A is to be taken Bhanu, then A is to be taken with Binoy, Chandra and Divya. Like A comma Bhanu, A comma Binoy, A comma Chandra, A comma Divya. Then there's a turn of B. Then you have to start with B. B comma Ali, B comma Bhanu, B comma Binoy, B comma Chandra, B comma Divya. Then you start with C. C comma Ali, C comma Bhanu, Binoy, Chandra and Divya. So these all are the ordered pair. Okay, and you can say they are the Cartesian product of P and Q. So that way they would have 15 ordered pair: A Ali, A Bhanu, A Binoy, A Chandra, A Divya, B Ali, B Bhanu, B Binoy, B Chandra, B Divya, and again along with C. So 5 in each. So you would have how many elements? The 15 ordered pair. You would have 15 ordered pairs. Ordered pairs. But what the relation, and you can say how the relation is associated with the ordered pair. Alright, so now we will understand what is the relation. So relation is like a condition, or you can say relation is like a rule that implies among the set A and the set B. Alright, so let's take an example of relation. See, R means the relation X comma Y such that X is the first letter of the name Y. X is the first letter of the name Y. That means this A is to be associated with the names that is starting with this A, like Ali. Alright, and there is no names that is starting with the letter A. So you can write A comma Ali under this relation. Alright, and now just look at the B and here Bhanu and Binoy, because the Chandra is starting with C, so you cannot take the Chandra along with B. So B comma Bhanu and B comma Binoy. Now check for the C. C is with Chandra because no other name is starting with C. C comma Chandra. So this relation gave you some condition, right? You have to take the names in such a way they're starting with their letter. Like Ali is starting with the A, and the Bhanu and Binoy is starting with B, and the Chandra is starting with C. So these names are to be associated with these letters. So you can see in the letter that is written in the roster form, in the set builder form, X comma Y, such that X is the first letter. X means the very first element. Okay, X is the first letter of the name. So the name is Ali, and the first letter of the Ali is A. You can see that is starting with this one, first letter. You can check in the second pair, the Bhanu is starting with the B, and B is over here. Binoy again B, and Chandra C. Okay, but there is no letter D over here that can associate your Divya. So that's why this is the relation. A Ali, B Bhanu, B Binoy, and C Chandra. Alright. So, and the second thing, whatever the relation you're getting, this is your relation. Okay. And this relation must be the subset of the Cartesian product. Hope you understand this statement. The relation must be the subset of the Cartesian product. So you see over here, when you are finding out the Cartesian product of P and Q, A Ali, A Bhanu, A Binoy, A Chandra, A Divya, B Ali, B Bhanu, B Binoy, B Chandra, B Divya. So these ordered pair will also exist in the Cartesian product. If this is not happening, that means you had made mistake somewhere. So the relation must be the subset of the Cartesian product. Okay. So according to my language, or the relation is a kind of rule or the kind of condition. Based on that, you have to write your ordered pairs, and those ordered pairs must be the subset of your Cartesian product. All right, and these ordered pair you can write in the arrow diagram like this, ABC, and they all are. And the second thing, what is the domain and what is the range? So the very first element of the relation, like you can see over here, the very first element is called the domain, and the second element is your range. So you can write here your domain is A, comma B, comma C. And what is your range? Your range is Ali, Bhanu and Binoy and Chandra. So this is the range. The first element is called your domain and the second element is the range. Alright, you can see over here the set 1, 2, 5, 7 here represent your domain, and A, C and N, A, C, N represent the range. So this is all about the relations. So now we will learn the type of relations. In the types of relation, first of all we will study the empty or the void relation. Then I'll talk about the universal relation, identity relation, reflexive, symmetric, transitive, and then equivalence relation. So they all are very important. Okay. So let's understand. First of all, the empty relation. Empty relation. So generally, I'm not writing the definition. I'm just taking an example just to make you understand. So I'm taking a relation A comma B such that A minus B equal to 15 for every A belongs to capital A and B is also belongs to, and A is already given here. One, 2, 3 and 4. So this is the example of the empty relation, because in the Cartesian product, like if you're finding out the A cross A, A cross A, so none of the ordered pair gives you the difference of 15. You can check, you can find out some ordered pair, you can check here. I'll show. Suppose if we find out the A cross A, so you would have the element like 1, 1, 1, 2, 1, 3, 1, 4, and 2, 1, 2, 2, 2, 3, and so on. And you observe the ordered pair, see the ordered pairs, and from any ordered pair you will not get the difference of 15. You can check. 4 minus 1 you are getting 3, 2 minus 1 you are getting 1, 2 minus 2 gives you 0, 3 minus 2 gives you 1. So none of the ordered pair gives you the difference 15. Alright, so such relations are called empty relation. Alright, so I will discuss the universal relation, identity relation, and the other relation in my next